In coordinate geometry, we discussed about parallel lines. We said when two or more lines are parallel to each other, they are going to possess the same gradient. Now, if you are wondering why this is true, then I'm going to show you in this video the reason why two or more parallel lines must have the same gradients. So let's begin our discussion with a coordinate plane. So considering the coordinate plane, which the vertical part is nothing but the y-axis, while the horizontal part is still the x-axis. Let's consider two lines that are parallel to each other. But first, do you really know what a parallel line is? They are straight lines that are moving towards the same direction but does not meet. So therefore, I'm going to consider the first parallel line to be in green color, and that will be moving along this direction. Then I'm going to consider the second one to be in yellow color, and that will be moving along this direction. Now we can clearly see that these two lines will never meet, but keeps on moving towards the same direction. So this is what we call a parallel line. So to show that, let me just put an angle at one end, showing where they are being directed to. Now, one thing about straight line is that if you are willing to calculate the gradient or the slope of a certain point on a straight line, it's going to be equals to calculating the same slope on another point on the same straight line. So, which implies that the gradient of any point on a straight line is the same. Keep that in mind. It's something you want to be familiar with. But that's not really the case for this video. I just want you to be familiar with that. Now, let's say that I want to calculate the gradient of a certain point on this line. What should I do? What can I do? You notice that these two lines, the green one and the yellow one, has already formed a triangle, which is a right one, by the two axes. You can clearly see that this is the first triangle formed by the green line, and this is the second one formed by the yellow line. So I'm just going to label the triangle PQO. And for this one with yellow line, that is going to be OBA. Perfect. Now, how can I find the gradient of the line joining point P and Q? To calculate that, all I need to do is to take the ratio of the distance of the line PQ along the y-axis to that of the line PQ along the horizontal axis. And that's going to provide the gradient of line PQ. So let's calculate that. So that's going to be equals to, well, for easy identification, let me label these points. This point will serve as y2 along the y-axis, while this point will serve as y1. This same point will similarly serve as x1, and this one will serve as x2. So therefore, the gradient will be given as y2 minus y1, all divided by x2 minus x1. Now, having done that, I would like to repeat the same process. So that of the yellow line. How can I calculate this gradient? So for instance, let's say this point is our x1, and this one will be our x2. If this is our y1, this will be our y2. So to calculate the gradient, so that will be the gradient of the line AB. Line AB. And that will be given as y2 minus y1, all divided by x2 minus x1. Now, can we figure out any similarity between triangle PQO and triangle AOB. Are they similar or congruent? What would you say? And triangle AOB. You notice that triangle PQ is similar to triangle AOB, and at the same time, it will only be congruent to triangle AOB if and only if the two triangles possesses the same size. But there are some cases whereby they don't possess the same size, and this doesn't alter the condition. The gradient will still be the same. So I would recommend to prove this deductive by using the similar properties, because that will always work in all cases. But keep in mind, you can always use the the congruent properties as well to show it out. But not going to use that because it might not work. It won't work in a case whereby the triangles are not equal in size. Though with what we are seeing, the triangles seems to be similar, to be equal in size. So now we can see that this is a right angle and this is also a right angle. So the two triangles possess something in common. So therefore they are similar. Similarly, this angle, if it is alpha, this one will also be alpha as alternate angle. At the same time, if this angle is beta, this angle will also be beta as alternate angle. So since we can use the postulate of angle side angle, that's angle side angle, to show that the two triangles are congruent, then we can use the congruence property, but we are not going to use that in this case. We are using the similar properties. So what says the similar properties? For you to know if two triangles or shapes are similar, just try to figure out something in common. Once they possess something in common, then they are similar. So since these two angles are vertically to each other, then therefore they have something in a relation. The both angle are 90/90s. Now, for similar triangles, it is expected of us to know that the ratio of the corresponding sides are the same, which means that the ratio of the vertical part of the first triangle to the vertical part of the second one has to be equal to the ratio of the horizontal part of the first triangle to the horizontal part of the second one. So let's see that. So for the first triangle, its ratio will be y2 minus y1 divided by that of the second triangle, which is to be y2 minus y1. This is going to be equal to the ratio of the second one. That will be x2 minus x1, x2 minus x1 divided by the ratio of this one, x2 minus x1, x2 minus x1. Very good. Now, for you to be able to identify this properly, don't forget these quantities are for the first triangle, which is that of triangle PQO. So what I'm going to do is that I will just put P on top of them. So you can note that they are for values for the triangle PQ. And for this, they are for the triangle AOB. So I'm just going to put AOB on top of them, just A, okay, for easy identification. Now, is there a way we can re-express this such that they will be equal to each other? And turns out that they is. So what I will do right now is to multiply both sides by y raised to a minus y raised to a. So 1 and 2 divided by x2 raised to p minus x1 raised to p. So I'm going to multiply both sides with this, and let's see what we are going to eventually result in. Okay, so let me get rid of this anyway. Well, I think okay, let me get rid of that. We don't really need this, so let me remove that. Now we have y2 raised to p minus y1 raised to p divided by y2 raised to a minus y1 raised to a. Excuse me. Then multiply by, I'm multiplying that with the whole things over here. That's y2 raised to a minus y1 raised to a divided by x2 raised to p minus x1 raised to p. Now, we can clearly see that y2 raised to a minus y1 raised to a will cancel each other, and we will be left over with y2 raised to p minus y1 raised to p, all divided by x2 raised to p minus x1 raised to p. So I'm through with the left hand side. So let's express the right hand side as well. So for the right hand side, I'll be having x2 raised to p minus x1 raised to p divided by x2 raised to a minus x1 raised to a to be multiplied by this. We are multiplying it with this, and that will be y2 raised to a minus y1 raised to a, all divided by x2 raised to p minus x1 raised to p. Now we can clearly see that this point as well, x2 raised to p minus x1 raised to p will cancel out, and we would be left over with, okay, that's going to be equals to y2 raised to a minus y1 raised to a, all divided by x2 raised to a minus x1 raised to a. Very good. Now, what is this telling us? What is it telling us? What would you say? Now, you can clearly see that y2 raised to p minus y1 raised to p, all divided by x2 raised to p minus x1 raised to p, is the gradient of the line joining PQ. So that's m sub PQ. And y2 raised to a minus y1 raised to a divided by x2 raised to a minus x1 raised to a is the gradient of the line joining point AB, and that will be m sub AB. And therefore, we have it to be shown and proved. The gradient of two straight lines that are parallel to each other on a coordinate plane will always be the same. Hopefully you find this helpful. If you haven't subscribed, please do and subscribe to my channel. Thanks for watching. See you guys in the next video. If you have any questions, feel free to ask in the comment section below, and I'm going to respond to you. Thanks for watching. See you guys in the next video. Bye for now.